Welcome to the Unravel View channel, exploring the wonders of our world and beyond. 66 million years ago, Earth was a lush, warm paradise. No ice caps, just endless forests and teeming life. Towering dinosaurs like Triceratops and Ankylosaurus roamed vast green landscapes, shaping the world as they grazed. Above, pterosaurs soared and early birds flitted through the trees, while small mammals scurried in the shadows, waiting for their moment. Life thrived in a stable greenhouse world, unaware of the disaster racing toward it from space. On what seemed like an ordinary day, the sun rose over a kingdom of giants, unaware that their reign was about to end in a fiery cataclysm. Far above, a 6-mile-wide asteroid, an ancient remnant of the solar system, hurtled towards Earth at 12 miles per second. Its mass, 460 trillion tons, carried energy beyond comprehension, enough to outmatch all nuclear weapons ever built. As it neared, it blazed through the atmosphere, creating a shockwave that would echo across the globe. In the sky, it appeared as a blinding growing star, a cosmic harbinger of destruction. The impact would unleash a force 1 billion times greater than the largest volcanic eruption in history. In a single moment, this asteroid would change the fate of life on Earth forever. The asteroid struck a shallow sea where the Yucatán Peninsula now lies, a spot loaded with deadly potential. At the time, this region was covered by warm, shallow waters, teeming with life and layered with thick deposits of limestone and ancient marine sediments. These seemingly ordinary features would prove catastrophic on a planetary scale. Only a few places on Earth could trigger a global extinction. The odds of hitting one were slim, but fate was not kind. The asteroid could have landed almost anywhere else and caused devastation, but not the end of an era. Instead, it found the one place where its impact would unleash the most destructive chain reaction imaginable. The impact vaporized sulfur-rich rock and hydrocarbons, blasting trillions of tons of toxic particles into the sky. These chemicals mixed with water vapor, forming acid rain that fell across the globe, while the dust and soot blocked out the sun, plunging the world into darkness. This chemical cloud would shroud the planet, blocking sunlight and poisoning the air. Temperatures plummeted, photosynthesis ground to a halt, and ecosystems everywhere began to collapse under the weight of this sudden, unnatural winter. The Chicxulub crater, over 90 miles wide, marked the site. Its formation sent shock waves and earthquakes across continents. The energy released was greater than billions of atomic bombs, reshaping the landscape in an instant and leaving a scar visible from space. Had the asteroid landed in deep ocean, the devastation would have been immense, but the global winter might never have come. The water would have absorbed much of the impact, and the unique chemistry of the Yucatan's rocks would not have been unleashed. Instead, the unique geology of Yucatan turned a massive explosion into a planet-wide catastrophe. The limestone and sulfur compounds acted as fuel, amplifying the disaster and ensuring its effects reached every corner of the globe. Life's trajectory was forever changed by a matter of cosmic geography. In a single moment, the fate of countless species was sealed, and the world as it had been was lost to history. The asteroid slammed into Earth with the force of billions of atomic bombs. A flash brighter than 1 billion suns vaporized everything nearby in an instant. A colossal air blast flattened forests for hundreds of miles, while molten rock and debris shot into space. The sky rained fire as this material fell back, igniting global wildfires. Mega tsunamis surged from the impact, scouring coastlines and sweeping away entire ecosystems. Earthquakes and volcanic eruptions shook the planet, compounding the chaos. For minutes, Earth became a vision of hell, blinding light, deafening sound, and incinerating heat. The age of dinosaurs ended not with a whimper, but with a cataclysmic bang. Minutes after impact, molten debris rained down, heating the atmosphere and igniting wildfires across continents. The sky became an oven, cooking the surface and filling the air with soot and ash. 15 trillion tons of this material joined sulfur aerosols, forming a thick black shroud around the planet. Sunlight vanished, plunging Earth into years of darkness and endless night. Photosynthesis stopped, plants withered, and oceanic phytoplankton died. collapsing food chains everywhere. Herbivores starved, followed by the carnivores that hunted them. Acid rain formed from vaporized sulfur, poisoned soil and water, making recovery even harder. The oceans turned acidic, dissolving shells and killing marine life. Earth became a cold, toxic wasteland, nearly uninhabitable for most life. The world as it was had ended. The blackout, freezing temperatures, and acid rain triggered one of Earth's greatest mass extinctions. This catastrophic event, known as the Great Dying, wiped out nearly 90% of all species on the planet. The skies were darkened by ash, blocking out the sun and plunging the world into a prolonged winter. Acid rain poisoned the waters, and the land became a barren wasteland. No land animal over 50 pounds survived. The mighty dinosaurs vanished forever. These colossal creatures, once the rulers of the earth, were unable to adapt to the sudden and harsh changes in their environment. Their extinction marked the end of an era. Their size, once an advantage, became their downfall in a world without food. The lack of vegetation and prey left these giants with nothing to sustain them. As the days turned into months, their numbers dwindled until none were left. Yet, life endured. Small mammals burrowed underground, surviving on scraps and insects. These resilient creatures found refuge in the shadows, their small size and adaptability giving them an edge in the harsh new world. They scavenged for food, making the most of the limited resources available. Turtles and crocodile ancestors, shielded in water, also persisted. Their aquatic habitats provided a buffer against the worst of the environmental changes, allowing them to survive when so many others perished. These ancient reptiles would go on to thrive in the New World. Plants slowly returned, hardy ferns sprouted first, marking the event in the fossil record. These pioneering plants were among the first to reclaim the devastated land, their spores carried by the wind to new locations. Over time, they began to cover the barren earth, setting the stage for further recovery. Over centuries, forests regrew and new life began to reclaim the land. The slow but steady return of vegetation provided habitats and food sources for the surviving animals. As the forest expanded, they created a more stable and hospitable environment. Mammals seized the opportunity, diversifying and evolving to fill empty niches. With the dinosaurs gone, these small creatures began to explore new ways of living, adapting to different environments and food sources. Their evolutionary journey had just begun. It took millions of years for large mammals to appear, and even longer for giants like blue whales. These new giants of the animal kingdom would come to dominate the land and seas, each adapting to their unique ecological roles. The asteroid reset life's course, ending the age of reptiles and paving the way for mammals, and eventually, us. This monumental shift in the planet's history set the stage for the rise of human civilization, a testament to the resilience and adaptability of life on Earth. If you enjoyed this journey through time, smash the like button and subscribe to the channel for more amazing stories from our planet's past. What if the asteroid had missed the Yucatan and struck deep ocean instead? The immediate destruction, mega tsunamis and earthquakes would have been immense, but the long-term effects far less severe. Without vaporized sulfur and soot, the sun-blocking cloud might never have formed. Photosynthesis could have continued and the food chain might have survived. Dinosaurs would likely have endured, their reign continuing for millions more years. Mammals would have remained in the shadows, their evolutionary explosion never triggered. Without the extinction, primates and humans might never have evolved. Our existence is a direct result of that random catastrophic event. The asteroid's impact cleared the stage for our story to begin. The world we know was born from the ashes of the one the dinosaurs lost. If a similar asteroid threatened Earth today, our technology would give us a fighting chance. Unlike the dinosaurs, we have the ability to observe the skies, track potential threats, and respond with unprecedented speed and coordination. Our global network of observatories and satellites constantly scans the heavens, searching for objects that could pose a danger to our planet. We'd likely detect it decades in advance, turning apocalypse into a global challenge. Early detection would buy us precious time to plan, to innovate, and to unite as a species. Governments, scientists, and engineers from every corner of the world would be called upon to collaborate, sharing data and resources to devise a solution. Deflection missions, kinetic impactors, gravity tractors, even nuclear devices could nudge it off course. These technologies, once the stuff of science fiction, are now being seriously studied and tested. The goal? To change the asteroid's trajectory just enough to miss Earth, sparing our world from devastation. If that failed, survival would depend on deep, self-sustaining bunkers shielded from fire, cold, and darkness. These shelters would need to support life for months or even years, providing food, water, and air while the surface recovers. Only the best prepared communities would have a real chance at enduring the aftermath. The Svalbard Global Seed Vault, a genetic library of crops, could help restore agriculture after the skies clear. This vault, buried deep in the Arctic permafrost, safeguards the genetic diversity of our food supply, ensuring that future generations could replant and rebuild. Preserving animal life would be harder, but genetic engineering and frozen embryos offer hope for key species. Scientists are already working to store the building blocks of life so that, one day, lost animals might be revived and ecosystems restored. Education and public awareness would be crucial too. Preparing future generations to understand the risks and solutions ensures that humanity remains vigilant and ready to act. Humanity's survival would hinge on cooperation, innovation, and long-term planning. Only by working together, across borders and cultures, can we hope to overcome such a monumental threat. The dinosaurs' fate is a warning. Life is fragile, and the universe is indifferent. Their extinction reminds us that no species is immune to cosmic catastrophe. We are the guardians of our own future, armed with knowledge and tools they never had. Our choices, our investments in science and preparedness will determine whether we endure or vanish. The lesson is clear: prepare, adapt, and never take survival for granted. Our resilience, creativity, and unity are our greatest assets in the face of the unknown.